Hi, I'm Vlad Ladezhansky, professor of biophysics here in the Department of Physics of the University of Guelph. So you saw probably those NMR magnets, right? These are they have very permanent magnetic fields. So what you have there is a coil. It's a little bit of kind of preface. So there's a coil immersed in liquid helium, and it cannot be turned off. So if something gets stuck inside the magnet, we're in a big trouble. Okay, so because you just can't take it out, though it's really, really hard. So that happened probably 1 week after I joined my master's degree lab. I was repairing a probe and I had a wrench in my hand and it got sucked into the magnet. So the wrench stuck there, and I really tried hard to take it out. I simply could not do that. I cut my hands because I pulled like a really, really thin wire. And then on the next morning, 2 more people helped me take it out. And that literally took 3 men to take it out, right? It was really, really hard. It wasn't funny at all, but now when I remember it, it is. I thought I would be fired, right?
Yeah.
Was born and grew up in Moscow many years ago. I studied at the Moscow Institute of Physics and Technology, majoring in hardcore physics. Then I moved to Israel, to the Weizmann Institute of Science, for my graduate MSc and PhD work, where I became exposed to magnetic resonance. And at that point, I became very interested in everything related to magnetic resonance phenomena. It's really an extremely versatile technique which can be applied to study small organic molecules, hard materials, biomolecules, etc., etc. So once I moved for my postdoc to the United States, to MIT, I became really exposed to biophysical aspect of NMR and spectroscopy by itself, because NMR, as opposed to many other techniques, is by itself a research field. So then I moved to Guelph. That was 2003, I think. Yeah, 20 years, and I met some of my colleagues here in the department, specifically Lenny Brown, who is a real biophysicist by education, and he really got me involved in some of the protein studies that we did. And since then, that's what I've been doing, studying membrane proteins by using NMR spectroscopy. We're talking about structure, function, interactions with other molecules, questions related to folding, as well as some of the medically relevant questions. Since I was 7 years old, I was really interested in chess. And that was my main area, and I was at some point contemplating becoming professional chess player, believe it or not, right? And I was always mathematically inclined, let's put it this way. So then towards the end of my high school, I realized that I'm not gonna make it in chess, because there are people much, much better than I was. And at the same time, I became communicating with our neighbor, who was actually professor of physics. And after that, I started reading biographies of different physicists, Landau, for example, books by Feynman, and I really enjoyed solving problems, believe it or not, right? Like physical problems. And so after 1 year of intensive studies, I ended up in Moscow Institute of Physics and Technology, studying physics, majoring in physics, and that's basically how it went, right? And since then, I've been enjoying it. As I mentioned, NMR is really a sort of field of research by itself, and that was my original, so to speak, interest once I started my postdoc and then came here to Guelph. But it is really applied science, so it is essential to have good applications. So we study membrane proteins that are found in cell membranes. They perform a variety of different functions, specifically light-sensitive molecules that absorb light and convert that energy of light into some kind of function. Can be production of proton gradient, for example, or signaling, etc. This is one aspect. Protein physical chemistry, I would call it, maybe. And that is like the energy landscape of molecules. When proteins are synthesized, they are synthesized, produced as polypeptide chains that don't have a well-defined 3-dimensional structure. Once they fold and become native, there's a complex energy landscape which represents sort of a totality of all interactions, electrostatic interactions, primarily in nature, that define what the molecule is going to be at the end of this sort of long pathway in the native state. How it happens, the details of that energy landscape is what we really study. We also look at protein dynamics, how molecules move. These are not rigid bodies. They have lots of internal motions on time scales ranging from picosecond to really seconds. Many of them are functional. Many of them simply represent intrinsic stability of molecules. This is, of course, of great interest. And more recently, I began collaboration with Scott Ryan. He used to be at Guelph, now he's in Calgary, who is really a neuroscientist. He is interested in, I would say, everything which is related to Parkinson's disease, right? And specifically, there's a protein called alpha-synuclein, which is the central player in this whole story. And we study how it misfolds and how these misfolding events could cause Parkinson's disease specifically. So our department is very collegial, and that's, I think, the main kind of attraction. People are very friendly, people like each other, people communicate really well, and we have great students, really, and I enjoy interacting with students, of course. I have 5 graduate students. Some of them are co-supervised, so I think 3 PhD students and 2 master students. And normally we also have 1 or 2 undergrads. So our research is really interdisciplinary. I don't like talking about physics versus chemistry versus biology, because for us it's really everything. And it's really sometimes hard to say. I would say they're involved in all aspects of the work, right? We try to tune it a little bit. So those who come with a biochemistry background will work more in the biochemistry field, physics, and biophysics more on the spectroscopy side. But overall, I would say students are involved in every aspect of the project, from sample preparation, which is some pretty simple microbiology and biochemistry, towards spectroscopy, which is physics, computer science to some extent, a lot of data analysis and things like that, right? So basically that's what students do. It's a pretty steep learning curve, I should say, for most, simply because, again, the field of spectroscopy is so complex, of NMR spectroscopy is so complex. I like challenges, and there are plenty of challenges in research, right? So these are problems that do not necessarily have a solution. And that's what really attracts me to those.